All right. Good morning, boys and girls. Thank you so much for joining us for our third and final virtual field trip with Miss Evelyn at the California Science Center. We've learned so much. This is the third and final one. The first one, if you remember, that Miss Evelyn took us through, she was really guiding us through what was an engineer, what is an engineer. The second one, we had Mr. Noor. He was taking us through what happens when you mix things along. And then the third and final virtual field trip will be guided around the question of how do materials respond to heating and cooling. So I'm going to turn it over to Miss Evelyn, who's going to walk us through an amazing, amazing virtual field trip today.
Hi, scientists. I'm so happy to be back with all of you once again. I hope you enjoyed last week's. And yes, like Miss Kim said, we have had some great time together. So, yes, our first session was all about engineering. What is an engineer? What kind of engineers are out there? And today I am in a very special place. So, behind me, you can see our Space Shuttle Endeavour, which is one of my favorite engineering things out there because so much work went into this and so many different pieces had to come together to make it work. And those engineers had to ask those questions. What happens when you mix things together? How do we get a brand new thing that's going to help us solve a problem? It also brought up that question of how are things going to react when it gets too hot and gets too cold? Now, like I said before, you are welcome to ask questions the entire time. So, Ms. Kim, feel free to interrupt me as many times as you want. Okay. I have lots of things that I want to show you. And really, if you have questions about this thing that's behind me, feel free to ask. And it's the real thing. There's no virtual background back here, scientists. It's me inside of the pavilion trying to give you a good view of our orbiter. So, if you have questions about anything you've heard or that you know, feel free to ask. Now, like Ms. Kim said, today we're talking about heating and cooling. And I am sure that all of you have experience with things being too hot or too cold. Here in Los Angeles, we have seasons. And depending on the time of the year, things feel different. And the outside world feels different. Okay. So to start, I am going to show you a couple things. I am going to pour water into this container here, and I have two containers. One of my containers has cold water in it. My other container has hot water in it. So it's the same thing. It's still water, but one of them is hot and one of them is cold. And what I am going to do is add a drop of food coloring. Now, I'm sure you all have some experience with food coloring. Sometimes it gets everywhere and it's not fun to play with. Now, while I'm doing this, I might have to move the camera up and down to give you better looks, but I am going to drop 2 drops of food coloring into the cold water. And let me wipe this down so you can get a better look. Ready? 1, 2. And check out what happens to it. I'm going to do the same thing with the hot water and bring it up for you to check out. So cold water, hot water. What do we see happening? Which one is spreading faster? Which one is spreading slower? I'll move this around. So which of these jars is getting fully green faster? And my question to all of you scientists, why might that be happening? Why might one be mixing, and I'll move this one the same way, faster than the other? So if we look at it now, this one, that food coloring has completely spread. This one, and I'll wipe it down so you can see it because there's a lot of condensation on the outside, still has pockets where the green has not spread. While this one, if you look at that green color, it's nice and all over the place. So why does that happen, scientists? That is what we're trying to figure out. Why do things react differently when it's hot or when it's cold? And I know it's not time for questions just yet, but let's just hold off on that one and see if anybody has any ideas to why that might be happening. Now, I will say that everything around us is matter. Okay, so what does that mean? The word matter. So when we say matter, we're not saying, hey, that matters. We're saying, hey, that's a thing. So a thing is anything that takes up space and has a weight. So can you think of that table that you're sitting on, or the chair, or the floor? All of that is a thing. It's made up of stuff that takes up space and has a weight. So even things that are solid, like the table or the ground, they're still made up of things. And if we had a good enough microscope and we were able to zoom in a lot, and like, I mean, zoom in a lot, you would see that everything is made up of these tiny little things that we call atoms. And even when an atom is making up a table that's solid, they're still moving. Yeah. So those atoms that make up everything around us are always, always moving. It doesn't matter if it's a liquid, it's a gas, or it's a solid. They're always moving. And it's that movement that affects them. And the temperature affects that movement. So let's think about something else that some of you might know about. How many of you have ever sat outside or looked out your window, whether you're in the car, whether you're at home, and you looked at clouds? How many of you have ever looked at clouds? Yeah. So what are clouds made up of? Any guesses? Give you a minute to think about it. So it's actually made up of this thing that you use all the time, that I just used in my experiment. It is made up of water. So when we think about the water cycle, that is a great example where heating and cooling is happening all the time. So think about the water cycle and how that moves and what is happening in that water cycle all the time. Some parts of it are getting warmed up, and that leads to what? Some parts of it are getting cold, and that leads to what? Now, do we have any questions? I know it's been a couple minutes. So any questions from any of our scientists just yet? Either about what happened with our two containers where one mixed a lot faster than the other, and the one that mixed faster was the hot one? Or thinking about the water cycle and the clouds that we've seen before?
Miss Evelyn, we can give our teachers and our students maybe about a minute or so to open up that Google form and go ahead and input any questions.
While we do that, and I'm just going to wait, I am going to put this bottle in front of you. And you see that my bottle has lots of circles, and those circles tell me the temperature. And while we're doing that, I'm just going to pump my bottle. It says me giving all of you time to come up with your questions. Just going to keep pumping and pumping. And you might see that something is changing. There's a color change in one of those dark circles. And that's because as I'm pumping, I am making it really warm inside of this bottle. And what I'm using to pump, scientist, this thing over here, is what I use to keep my soda nice and fizzy, which means I am pumping air inside of this bottle. And the more air molecules that are in there squished together, the harder it becomes for me to pump. And that means that those air molecules are pushing against each other even more. Like they're really pushing against each other, which makes them really hot, really, really hot. So when I let cold air in from around this room, so the air in here is a little bit warmer than the air out here, watch what happens. I get a cloud in a bottle. So once again, how is it that that's happening? And I think I've said it a couple times now, because we are messing with what? And it was part of our question. We were thinking about what is happening when you heat or cool things. And what you're doing when you heat and cool things is that you make things crash against each other or move more or less. So gases, liquids, and solids all react differently, but they're always moving. And when you add heat, they move more. When you make it cold, they move less. And that affects how everything works. Now, the reason I wanted to be in this room was because this thing, when it goes up into space and there's no air around it and it's just orbiting Earth doing the work that it needs to do, sometimes it can get really hot and sometimes it can get really cold. And it was a big engineering problem because we needed to build something. And by we, I mean the scientists and engineers that worked on this needed to build something that was going to do well, whether it was really hot or whether it was really cold. Because a lot of the time we think of space and we think of really cold. But as we are rotating, sometimes as it's rotating, sometimes it faces the sun and then it's really hot. And then it's on the other side and the sun's not around. And then it's really cold. So those materials need to be able to do well when it's really hot and really cold. So when things are really hot, things or items tend to expand. Can everybody say expand? So think about when you put air into a balloon. That latex of the balloon is expanding. It's getting bigger. It's taking up more space. But when it gets really cold in space, things get smaller or they contract. They get much, much, much smaller. So scientists had to figure out, how are we going to make something that can do well when it's really, really hot and when it's really, really cold? Because in space, it gets really, really cold, like really cold and really hot, which is why those astronauts have to wear spacesuits to always protect themselves from how hot and how cold different things can be. So in space, we need to build something that's going to take us up there. We need to build it in a way that it can withstand the hot and the cold, or that expanding and the contracting, and something that will protect the astronauts that are up there while they're doing their work, because they also can't get too hot and can't get too cold. I know we here are always protecting ourselves from getting too hot and getting too cold because our bodies are not used to those extreme temperatures. Now, I love cloud watching, and I can tell when the different clouds were made by how that cloud is formed. And all I'm doing is making it really hot in here. And when I pump this open, that colder air from in here goes inside and it creates condensation, just like when we see clouds outside. When it's really hot, the water evaporates and goes up into a higher place that's much colder, and those water droplets start to attach to one another, and we start to see different types of clouds. And we can tell which one's a rain cloud and which one's not a rain cloud by how clumped together they are or not clumped together they are. So if you ever get a chance to really look up at the sky and observe clouds, you could learn a lot about what was happening a couple days ago, like how hot it was, or what's going to happen in a couple days from now as you watch those clouds. And all of that has to do with heating and cooling.
All right, we have a question, Miss Evelyn.
Yeah.
This is from Azri from Miss Lancaster's class. She asked a couple of questions. The first one was, why does the hotter one mix better? And then, are there materials getting bigger when it gets cooler or when things get heated and it gets hotter?
Oh, that's a great question. So the first question was, why does the hot water mix faster? The molecules or the stuff in the hot water, those tiny little atoms that I was talking about, are moving around faster in the hot water. Heat makes things move around more in that tiny molecule level. So it mixes faster all on its own without us even having to do anything. The one in the colder water, those molecules are not moving around as quickly. So it takes longer for it to mix. So that is the difference between the hot water and the cold water. So usually when you want something to dissolve or mix faster, you heat it up to speed up that reaction, right? And in this case, we wanted to speed that up. I just wanted to show you what would happen from one to the other. And the second question was, do all materials contract and expand?
Mhm.
They all can. They definitely can. Now, here on Earth, we don't get to see it as often because we don't have as extreme temperatures as you would in space, which is also really cool. Now, I have an example of space, but think of ice when it cools. Okay, we take water, we put it into a tray, and we put it in the freezer. And those ice cubes actually do the opposite. They expand when it gets cold, which is totally not what we expect. Usually it's hot things that expand and get wider versus cold things get smaller. And that's because those molecules are moving around less. And I keep saying the word molecule and atoms, and they're the tiny little things that make up everything. Now in space, and if you look at my space shuttle behind me, you'll see that the bottom side of it is dark and black. But all over it, there are tiles, and those tiles are a little different. So I have an example of one right here. So this is a tile, and I have to be really gentle because this part is actually really easy to hurt and break. It's made up of glue and silicone, which is another way of saying sand. And when I tilt it to the side, you'll see that it is attached onto another piece of felt that's attached onto another larger piece. So each tile gets attached to the orbiter with a piece of felt. So when it's in space, these tiles can get bigger and smaller depending on the temperature that they're experiencing. Any other questions so far?
Not just yet, Miss Evelyn.
So this is one of the ones that I really wanted to show you because this is not something that we ever get to do when it's open. So if anybody ends up having questions about clouds, just let me know. I will take this out again. Now for this other part, I might need to move the camera just a little bit, and I do need to put on some safety gear because I am going to be using some fire, which can be really fun and also a little dangerous. So I am going to protect my eyes, put some goggles on. I am going to wear special gloves for my hand. And I only need it on one hand. And it has to do with this other thing that I showed you earlier. So the orbiter, when it's coming back from space, is falling through the sky really fast. We don't use any fuel. It's just falling. You can think of it as a glider. If you've ever made a paper airplane and you're just throwing it and it's moving across the room, that is what driving the orbiter is like when it's going to land on Earth. It's just falling really fast. And there's this thing all around us all the time that takes up space. So everybody take a deep breath and let it out. What do we breathe? And sometimes I get two different answers for this. What do we breathe? Some people like to say oxygen because what our body uses is the oxygen that we breathe out of the air. But air is a thing. Even though we can't see it around us all the time, it is always taking up space. So any place that you think is empty, it's not empty. It's actually full of air. It's this thing that's all around us. And the orbiter is also a thing. So when we have those two things come together and collide, we create friction. So go ahead and rub your hands against each other. And you can feel that heating up. That is friction. It's those two things rubbing against each other. And then you can compare that with like your pants or your shirt. Does it get hotter or faster or slower than when it's your two hands? Either way, the friction is still there. And for the orbiter, it can get really, 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 really hot. So these black tiles that I'm telling you about can get really, really, really hot and still be okay because sand can withstand being in really, really hot temperatures. Like when we want to turn sand into glass, it takes a lot of temperature. So I'm going to very gently show you what we can do. Did everybody see what color that middle part turned? It was red because it was so hot that it was at the point where it could start changing from one state to another. But as we touch it, totally fine. And that's because it's designed to be able to withstand that amazing amount of friction that's on it. Now, I know that all of you are building glue or trying to make some glue. And these tiles are special because the really hard part was figuring out how they were going to get them onto the orbiter. If they glued them or attached them directly to the orbiter, there wouldn't be enough space for them to expand and move and change. So what they did instead was attach them to a piece of felt like this. So they would take the piece, put it underneath it, and then attach it. So this piece can expand and contract as needed while they're in space and while they are coming back onto planet Earth. Any questions, scientists? I know that's a lot of information, but that glue can get complicated to make because when you use glue, sometimes there's a little bit of air trapped on the inside of it. So what they would have to do is put the glue in a special container, mix it, put it in a vacuum, suck out the extra air molecules that are hiding in the little pockets or bubbles that air has, and then they would be able to use it. Because if they just used it regularly like we do, when it's in space and there's no air around, it would also expand and move, which means these tiles would then fall off. And that's definitely not something that we wanted to happen because that would make it very dangerous for the astronauts that were coming back to Earth.
Miss Evelyn, I think that there's an active discussion probably happening in class. I don't see any other questions right now.
Well, I can share my favorite thing about the orbiter. So if you look behind me, and I might move us just a little bit to make this a little bit easier. A lot of the time, the number one question that I get about the orbiter is, what did it do? And that is a great question. So let's come closer. I'll pan up for all of you to see. So you can think of the orbiter as a pickup truck. So its big mission was to help build the International Space Station, which is a giant space station where lots of experiments and observations happen that is just going around planet Earth. So when you look at it, you might see where it says Endeavour, where the name of the shuttle is. And that is where the astronauts would hang out. They could only hang out in the front. When you look at the back, that's like the back of a pickup truck. It's open and exposed to space the entire time they're up there. So they can't hang out out there because that would be very, very dangerous. Instead, they would put things like satellites and pieces that they needed to be able to build the International Space Station. Now move it around a little bit because the orbiter is really big. One of the biggest animals on our planet is a blue whale. And this is actually bigger than that by just a little bit, but it's still bigger than it, which is pretty amazing because it took a lot of work and a lot of engineering to get something this big and this heavy to make it out into space. That's my favorite thing because sometimes when I was younger, I thought they could just walk up and down the entire thing. And when I started working here, I found out that that is not the case. And I also thought that it went to the moon, which was also wrong. But I learned that it did help build the International Space Station and that there's other things that we use to be able to make it to the moon.
Thank you so much, Miss Evelyn. That was a great, great response to the question. I mean, that's a question that I was actually having. So thank you so much for that.
Any other questions from our scientists at home? I know it's Monday. I get it.
It's Monday, and I just really predict that there's going to be a lot of active questions for their teachers as soon as we log off as well. So the learning continues.
So scientists, if you have any other questions, you can have them sent over to Ms. Kim, and I will do my best to answer them. If you ever get a chance to come back and visit us, this is one of the places it's always open because it has so much space. And as you walk around, you can see how big its engines were and how the engines are only used when they're taking off. They don't use them while they're in space, which was another thing that blew my mind when I learned about it. And you can see what it's like to have a lab in space, which is just a big room that looks like it has a lot of storage containers. But because in space you're floating, it doesn't matter where different things are stored. So you could sleep on the roof if you really wanted to. It's kind of fun to see.
All right. Thank you so much, Miss Evelyn. Boys and girls scientists, thank you so much. And thank you to Miss Evelyn for taking us through these 3 virtual field trips with us at the California Science Center. I encourage you to join and really log in and attend these virtual field trips as much as you can. The first one we really talked about was what was an engineer. The second one that the scientist Nora took us through was what happens when you mix things. And today's last guiding question was about how materials respond when we heat and cool things. So I hope you really enjoyed these 3 virtual field trips again at the California Science Center. I hope you will take your families and visit soon. Thank you so much.
Thanks, scientist. Bye.